Case study: AI integration in cybersecurity, enhancing threat detection and response in financial institutions. Sophia sat at her desk, staring at the multiple monitors displaying vast streams of data. She was the Chief Information Security Officer at a leading financial institution, tasked with safeguarding sensitive information from relentless cyber threats. The integration of artificial intelligence into cybersecurity had revolutionized her role, offering advanced tools for threat detection, prevention, and response. Sophia's day began with a review of the latest incident reports generated by their AI-driven security information and event management system. Overnight, the system had flagged an anomaly, a user account accessing sensitive financial records during unusual hours. This raised a critical question. How can AI's anomaly detection capabilities be leveraged to distinguish between legitimate and malicious activities? Her team, equipped with machine learning algorithms, had been trained to recognize patterns of normal behavior using unsupervised learning techniques. By continuously monitoring and analyzing user activities, the system established baselines for normal behaviors. Deviations from these baselines, such as accessing data at odd hours, triggered alerts for further investigation. Sophia and her team delved into the details of the flagged account. They noticed the access attempt originated from an atypical geographical location. This prompted another question. How significant is the role of contextual data in enhancing the accuracy of AI-based threat detection? Contextual information, such as the user's location, device type, and past behavior, was crucial in assessing the legitimacy of activities. By integrating such data, the system could better differentiate between benign anomalies and potential security incidents. While investigating the anomaly, the team also employed natural language processing tools to analyze the logs and emails associated with the suspicious account. NLP algorithms allowed them to sift through vast amounts of textual data quickly, identifying phrases and patterns indicative of phishing attempts or social engineering. This led to a thought-provoking question. What are the limitations of NLP in identifying subtle, context-specific threats? Although NLP was powerful, it required continuous training and updates to remain effective against evolving language patterns used by cybercriminals. As the investigation progressed, the team discovered traces of malware in the network logs. They turned to their deep learning models, designed to identify complex patterns in data that traditional methods might miss. The DL system quickly confirmed the presence of a sophisticated malware variant, prompting another question. How does deep learning enhance the detection of advanced persistent threats compared to conventional methods? DL's ability to process and analyze vast amounts of data in real time provided a significant edge in identifying and mitigating sophisticated threats that could evade traditional detection systems. Sophia's thoughts shifted to the broader implications of their findings. The malware was identified using a labeled dataset of known threats, a classic application of supervised learning. This raised a critical question. How can supervised learning be effectively utilized to keep pace with the ever-evolving landscape of cyber threats? The team had to ensure their models were regularly updated with new threat intelligence to maintain their effectiveness. Additionally, Sophia considered the importance of reinforcement learning in their dynamic environment. By training AI agents to adaptively respond to new threats, they could develop more resilient defense mechanisms. Reflecting on the ethical dimensions of their AI systems, Sophia pondered, how can organizations ensure fairness and transparency in AI-driven security measures? Bias in AI models could lead to discriminatory outcomes, such as false positives disproportionately affecting certain demographic groups. Ensuring that their training data was representative and continuously monitoring their models for biases was essential to maintaining trust and effectiveness. Sophia and her team also faced the constant challenge of adversarial machine learning. Attackers often attempted to deceive AI models with specially crafted data. This led to a crucial question. What steps can be taken to defend AI systems against adversarial attacks? The team had implemented robust defenses, including techniques to detect and mitigate adversarial examples. Continuous research and collaboration with the broader cybersecurity community were vital to staying ahead of adversaries. As they concluded their investigation, the team initiated their AI-driven incident response protocols. The AI system automatically isolated the compromised systems, applied security patches, and initiated recovery actions. This highlighted the importance of automation in reducing the time and effort required from human responders, raising the question, how can AI-driven automation enhance the efficiency of incident response and recovery? Automating routine tasks allowed the team to focus on more complex aspects of incident management, significantly improving their overall response time. The integration of AI into their cybersecurity framework also necessitated a zero-trust architecture. This approach emphasized continuous verification and monitoring of all users and devices, regardless of their location. The AI system provided real-time monitoring, adaptive authentication, and anomaly detection, ensuring that only legitimate activities were allowed. This led to a reflective question: how does zero-trust architecture complement AI-enhanced security measures in mitigating both internal and external threats? Finally, Sophia considered the critical aspect of privacy and data protection. AI systems required large amounts of data to train and operate effectively. Ensuring compliance with privacy regulations, such as the General Data Protection Regulation, was paramount. This raised an essential question: how can organizations balance the need for data access with the protection of individual privacy? Techniques such as federated learning and differential privacy helped address this challenge by enabling AI models to learn from decentralized data without compromising privacy. In conclusion, the effective integration of AI into cybersecurity required a deep understanding of machine learning, deep learning, natural language processing, and big data analytics. By leveraging these technologies, organizations could enhance their threat detection, prevention, and response capabilities. However, addressing ethical considerations, adversarial threats, and the need for explainability and scalability was crucial to ensuring the responsible use of AI in cybersecurity. Continuous advancements in AI and a proactive approach to addressing these challenges would enable organizations to stay ahead of cyber threats and protect their critical assets.